In this video, we'll continue our discussion about the Spring framework. Specifically, today we'll see how to use Spring to create a MVC web application, as well as how Hibernate and JPA are integrated with Spring. Later in the course, we actually will not use Spring MVC to develop our projects. Instead, we'll use Spring Boot, which is something based on Spring, but configures and runs quite differently from a Spring MVC web application. We'll also be developing REST Web API instead of a MVC web application, which means we don't need the view in MVC. So why are we discussing Spring MVC instead of jumping right into Spring Boot? Well, there are two reasons. First, Spring Boot has lots of details about how Spring works. So without knowledge of Spring, if you start with Spring Boot right away, everything just looks like black magic. And second, Spring Boot is still Spring, so you'll still be using Spring annotations, writing Spring controllers and DAOs and so on. So in this video, we'll cover lots of Spring web development basics that will still be useful after we move to Spring Boot. We'll discuss these things using an example I called Spring and Hibernate from scratch. So, as the name says, it's basically a guide on how to create a Spring Web MVC application that uses Hibernate for database access. We'll create such an application and we'll explain things along the way. So first, let's create a Maven web application. So we have done this before. Let's start with a Maven project. And we'll create a simple project without using archetypes. And let's make up a group ID. So I'll call this 5220 examples. Artifact ID will be Spring MVC. The packaging will be WAR, so it's going to be a web application. And this is what it looks like, and we need to customize it a little bit. So the first thing is we want to use JDK 1.8 instead of the default 1.5, and also I want to add a couple of dependencies right away. The first dependency is Servlet API. This one is needed if we want to use HTTP servlet requests or HTTP servlet responses directly. And the second dependency is JSTL. If you remember from CS3220, it's a tag library in a JSP file. So let me grab this and let me put it here. And then we need to do one more thing. We need to create a web.xml file, and for a Maven web project, the web resources should be placed under web app, and we want to create a web.xml file, so create a folder under web app called webinf, and then create a file called web.xml. And this is another file that we saw in CS3220. In CS3220, we didn't really need to use this file much, but when we move to a Spring web application, we do need to utilize this file, as we'll see later on. So this is going to be what the web.xml file looks like. Right now there's really nothing much in there. There's a welcome list, so when request path matches a directory, instead of listing the directory, we'll serve index.html file instead. And after all this, we can do a Maven update project and update this project, and it should make everything ready. Yeah, I think so. We'll find out. So now this is the Maven project, and then let's add Spring. So again, follow the follow the guide. We need to add 1 or 3 dependencies. The first one is definitely needed. We need the Spring Web Mvc dependency. So let's add that. So org Spring Framework, Spring MVC is here, and the current latest release is 5.2.8. And you may or may not need the other 2 dependencies depending on the JDK version you're using. I think I'm using JDK 8, so let's quickly check. Install JIEs. I actually have both 11 and 8, and this one I'm using 8. So I think I don't need the other 2. The difference between 8 and 11 is that in 11, they have split it out a number of packages that's considered Java EE packages out of the standard JDK. So previously they're included, but in 11, you have to include them separately. I think I'll be okay. We'll find out. Now, we'll also need to add this to web.xml. So web.xml is a Java web application standard configuration file. If you remember, is the so-called web application deployment descriptor, and inside you can specify some servlets. You can specify what URL patterns are mapped to certain servlets and so on. And here, this is the first important thing, the so-called front controller of the Spring framework. So notice that in web.xml, we specified a servlet, and this servlet is from the Spring framework. It's called the dispatcher servlet. We give it a name, and then we specify that any requests that end in .html will be mapped to this servlet. This is known as a front controller, and this is a very commonly used design pattern by web frameworks. A front controller is basically the entry point to the framework. Everything goes through the front controller will be handled by the framework, and anything else will be handled by the application server itself. In our example, notice that only requests end in .html are handled by Spring. For example, if the request is for a JPG image, it will be served by the application server instead of going through Spring. So if a request is mapped to the front controller, Spring will do another round of URL mapping to map it to a controller method later on. So that means we need to continue to do some configuration. So after changes to web.xml, we need to create a Spring bin definition file. And if you remember from the Spring IOC lecture, a Spring bin configuration file looks something like this, where you either specify a number of bins directly, or you do something called annotation driven and component scan to use annotation to specify beans, or you do a combination of the two. The bean configuration file is Spring MVC-servlet.xml, and specifically, the first part of the file name needs to match the servlet name, and the second part is -servlet.xml, and just like web.xml file, it needs to be under Web Inf. So let's create that file, and it's called Spring MVC servlet.xml. And let's copy over this. So if you look at this, we've seen annotation driven before. It basically says we are going to use annotations to specify beans, and we also saw component scan before. It basically says Spring will scan certain packages and its sub-packages to pick up those annotated beans. There's also something called internal resource view resolver bean, which we'll get to in a moment. So what this one says is that we need to create some controller beans, of course, and we need to put them somewhere under this package, Spring MVC.web. So let's do that, and we'll create a controller, and controller, of course, is Java. So in Maven project, it should be under source main Java, and let's create a class. I'm going to put it under Spring MVC.web.controller, why not? And I'm going to call it index controller. So in this index controller, the first thing I'll do is I'll annotate it with controller. So if you remember, when we talk about beans and wirings, we said that there are several annotations that you can use to define a bean. If it's a general bean class, you use component. If it's a controller class, use controller. If it's a DAO implementation class, use repository, and so on. So this one is going to be a controller, and notice that unlike servlet, it doesn't need to inherit from any superclass. All you need to do is just say it's a controller. And then inside, we can create a controller method which handles a request. So I'll say index method, and it returns a view called index, and I'm going to map this to index.html. So this is where the second level of request mapping happens. So if a request is mapped to the front controller, the front controller loads the bean definition file, find all the controllers, and then based on the request mapping of the controller methods, it will find a method that handles this request. So here we're using request mapping, and we're mapping this method to /index.html. So hopefully it will get called when a request comes to that URL. So later on, we'll see a little bit more about request mapping. In particular, you can specify additional attributes for the annotation to specify what method you want to map to a method, what parameters needed in order to map to a method, what headers needed in order to map to a method, and so on. When you have time, please check out the documentation. reading documentation is important. So in particular, you can see that there are some shortcuts of request mapping. You can combine the request method and the request URL by doing get mapping, post mapping, put mapping, and so on. So now we have the controller. We need to create a view, and the view will be a JSP page, and I'm going to create a folder under Web Inf, and then I'm going to create a JSP file called index.jsp. Well, I want UTF-8. Let's see if we can quickly change it. So HTML is already UTF-8. I want JSP ones to be UTF-8. Okay, UTF-8, great. And this one will be, let's call it Spring MVC, and of course we'll do a hello CS50. Okay, so now we have our view, and we'll explain a little bit later how the controller connects with the view, but let's run this and make sure it works. I never defined the server. Let's get a Tomcat 9. Let's use this one, why not? Actually, let's not use that one. Okay, let's use the one in CS50 to 20 and allow. Okay, so it works. That's great. Notice that the URL is a Spring MVC, not Spring MVC index.html. That's because we have specified the welcome file to be index.html. So going to this path is the same as going to this path. So either way, we are going to see this. We have seen the request comes from here, getting to front controller. Front controller loads the bin definition file, find all the controllers, map to a controller method, which comes to here. Then what happens with this one? So this doesn't seem to be the same as index.jsp under certain folder. And that's because in Spring, after the request is processed by the controller method returns a view name. So this one is a string, and it's not a path, it's a view name. And this view name then later will be resolved to a view implemented by a view resolver. The view resolver for JSPs is called internal resource view resolver, which is this one. And The view resolver needs to be configured as a bin with two properties, prefix and suffix. As you can see, the view resolver simply combines the prefix, the view name, and the suffix to get the path to a JSP file. And because my JSP files are under webinf/JSP, that's why the prefix is webinf/JSP, and combine that with the view name, and then the suffix JSP, and that gets us the path to the JSP. So you may be wondering why we need an additional layer of view resolution. Why don't we just return the path to the JSP file instead of something called a view name? The answer is that Spring supports many different view technologies. For example, we can take a quick look. And if you look on the left-hand side, the navigation menu here, you can see that it supports something called theme leaf, free marker, groovy markup, script views, JSP, tiles, RSS, and atom, the feeds, and PDF and Excel, and even JSON using Jackson, XML, XSLT views, and so on and so forth. So Spring supports lots of different views, and having this extra step of view resolution allow Spring controllers to have a consistent way to return a view. Spring controllers just need to return a string as a view name regardless of the underlying view technology, and the view resolver automatically figure out how to resolve that name into a view. So now we have controllers and views, but what about models? What if we want to pass some data from controller to a view? In Spring, you can add a model map as a parameter to your controller method, and then we can add whatever data we want to pass the view to this model map, and then later on inside the JSP we can use expression language to access those data, just like what we did in CS3220. So for example, if I can put this is a part that I really don't like. Eclipse, for whatever reason, it always autocomplete put into something else. So we're going to put something called name into the model map, and we'll say, yeah, why not? And then inside the JSP, we can, instead of saying hello CS3220, we'll say hello name. And if we refresh, we see John. So you can of course pass additional data to the view. Model map is really just a map, just like any other Java map. You can put key value map entries in it. So let's quickly recap how a request is processed in a Spring Web MVC application. So first, when a request comes in, the application server look up the web.xml file and map the request to the Spring Front controller, or in other words, the dispatcher servlet. The dispatcher servlet then consult the controller URL mappings, which are specified using annotations. And then map the request to a controller method. The controller method will process the request, produce some model objects, and return a view name. Remember that thing is called the view name. Based on the view name, the Spring framework will locate a view implementation like a JSP page and pass the model objects to the view. The view receives the models, renders a response, which will be sent back to the client. So now we are clear about how a request is processed. Let's add database to the mix. So the first thing, of course, is again dependencies, and let's see what dependencies we need. The first thing we need is Hibernate entity manager. So first let me stop the server, and let's add entity manager. So this one is from Hibernate, and then we need the Spring ORM package. So as the name says, it's the Spring integration package that integrates ORM libraries with Spring, including JPA, Hibernate, and all the others. And this one will be again from Org framework. So make sure we have the same version numbers for all the Spring packages. And then we need the JDBC driver for our database, and that will be MySQL. And then we'll need one more thing, which is so-called database connection pooling library. So connection pooling, in case you don't know, is something that helps you to maintain a database connection pool, so that instead of having to open a connection to run some SQL and then close it and open it again, which is very expensive, it helps you to keep a pool of opened connections. Every time your application needs a connection, just grab it from the pool. Once it's done, it simply release it back to the pool instead of closing it. That improves performance tremendously, because opening and closing a connection is a very expensive operation. There are several connection pooling libraries in Java, several popular ones. DBCP in particular is quite popular, as it's a Apache project. Tomcat JDBC is a simplified version of DBCP. It used specifically with Tomcat, and if you don't need additional features of DBCP or additional support for other application servers and so on, Tomcat JDBC is the better option. And since we are using Tomcat, we'll use Tomcat JDBC for connection pooling. And I think our server is 9.0.37, so we'll choose this, although I think other versions will work too. So now we have all the dependencies, and let's add the persistence.xml file. Remember, we need this file in order to use JPA. So let's create that file, and that one should be under resources, and then meta-inf. Let me I created it as a source folder. So meta-inf, and then it's called persistence.xml. And we'll copy over this one. So this one says the persistence unit is going to be called Spring MVC. It's going to be provided by Hibernate, and we are going to use MySQL 8 dialect. Okay, so looks okay. If you compare this one with the one we used in Hibernate, where is it? You can see that in Hibernate we have quite a few additional things. In particular, all the database information like database URL, user and password are in persistence.xml. The reason they are different is because for this one I want to specify those in Spring configuration file rather than persistence.xml. In other words, I want Spring to control the creation of the connection pool, transaction, and so on. So all that it will be in Spring configuration file. Then we need to modify web.xml a little bit. So come here and as this one. So we're adding two things. First is something called the context loader listener. What this listener does is it basically loads a second Spring Bean configuration file for, I guess, by convention, Spring web applications typically use two Bean configuration file, one for web-related things and one for non-web-related things like database access and so on. So this one loads the second configuration file, and then it also defines a filter. This filter is something called Open Entity Manager in View filter. What it does is really that it allows us to do lazy loading in JSP, because without this, Entity Manager will be closed after a controller finish generating the model. And then later on, if in your JSP you access model property that incurs lazy loading, you'll get an exception that says Entity Manager is closed. By having this filter, Entity Manager will be kept open until view is rendered, so that our code can use lazy loading in view. So now we have that, and then we need to add the second Spring Bean configuration file. It's called application context.xml. Let's create application context.html, and let's copy over all this. Okay, so to save time, I'm going to just use the same database that we used for the Spring Hibernate examples. So let me copy over the stuff. We need this one. Which is this one. And driver class, I think I don't need this. Especially, I think the new driver class is different. Let me see if we can skip that. And then username and password. Okay. So in this application context.xml, we need to define a number of beans. You don't really need to remember the name of the bins and so on. If you do need to create a Spring MVC web application, just copy and paste. These are kind of cookie cutter configurations. And for us, especially, we are going to use Spring Boot, which doesn't need all this configuration. But still, worth some explaining, because it kind of tells you how Spring handles data access and transaction management behind the scene. So this bin is what Spring uses to create a data source that connects to the database. And then there's an entity manager factory bin, which create entity managers. If you remember, we had something like this in the Hibernate example. And this one uses a persistent unit name, Spring MVC, which of course should match this name. And then there's a transaction manager, which is connected to the entity manager. This one will handle transaction management. And then there's also a exception translation processor. If there's any exception happens, which they will, then this one handles the exceptions. So here again, there are some annotation-driven configuration stuff, and so annotation config enables annotations like auto-wired and persistence context, which we'll see in a moment, and transaction annotation driven. This one enables annotations like transactional, which automatically adds transaction management in our code. In Spring, transaction management is actually added using aspect-oriented programming, so we don't have to say transaction begin, transaction end. We just need to specify annotation, and then that additional code is automatically injected. And okay, so we're done with configuration, I think, and let's write some code. So the first thing is we need some model class. So let me grab some model class. So we will want to put it under Spring MVC model so that later on they can be scanned and found. So I'm going to create a model class called employee, and it's going to be under spring.mvc.model. And I'm going to copy over the employee class from here, so we don't have to rewrite everything. What did I put? Okay. Control C, Control V. Okay. So this is the employee class, and okay. CSV server. Okay, so this is my database on CS3, and right now I have 3 employees, Sue, Joe, and Pam, and this is a Hibernate sequence, and then currently the next value is 104. So now we have the model class, and let's create the DAO. So usually we'll have an employee DAO that defines the interface. So let's say we want a list of employee, and we'll say get employees, and then we'll also want why it doesn't let me import. Okay, so import list first, and then import employee. Okay, and then we want to do a get employee by ID. Is it integer or int? It's an integer, so let's do an integer. And then we need to save an employee, so we'll do save employee and employee. Okay, so this is the interface, and then let's create the implementation, and we'll create a class called employee DAO implementation, and we're going to put it in the JPA package. And this one is going to increment employee DAO. Let's import first and then add. Okay, so the very first thing we do is we need an entity manager, and we'll annotate it with persistence context. I believe that's the one. Yeah. So remember when we talked about Spring dependency injection, we said that you can wire certain bins into certain other bins, and typically you would use something called auto-wired. And auto-wired is indeed the one to use for most cases, but entity manager is such an important thing. It gets basically an auto-wired annotation just by itself. So when you say persistence context, what it means is please inject an entity manager into this bin, and then we can use entity manager later on without doing anything ourselves. And also we need a repository annotation here to make this thing a bin. So remember, if we want a controller, we'll say it's a controller. And if we want a regular bin, we'll say a component. If we want a DAO bin, a database access bin, we say repository. So now we have the repository, which makes this a bin. We have persistent context, which gives us entity manager, and then we can do stuff. And so get employees. How do I get employees? I haven't done this for a while. We cannot do find. We'll have to do query, I guess. So we'll say create query, not create name query. Create query string class. Okay, so this one. So we'll say from employee, and the result class is employee.class, and we'll say get result list, something like that. Hopefully it will work. And then get employee, we can do a find entity manager find. So it's class and primary key. So we'll do employee class and then primary key, and then save employee. We'll do entity manager merge. So this one will merge it and then return a managed one. If you remember, in our Hibernate code, whenever we write to the database, like save something into the database, we have to use a transaction. In Spring, we don't have to say transaction begin, transaction end, catch the exception, and so on. I just need to say transactional. So Spring AOP will automatically inject. It's this one, not will automatically inject transaction management code. So that's pretty nice. So now we have our database access code, we have our model class, and repository, persistent context, transactional, and let's write some controllers. So the first thing we'll do is we'll list all employees, and again, hopefully it will work. What do we do? Go to controller here. Let's create a controller. I'm going to call this employees controller. And this one is going to be a controller. And this one is employee DAO. And we'll do auto word, so we automatically get that. And then we can write our controller method. So we'll say public string, let's just call it a list. And this one will say, well, we do need a model map. Let's say models. And this one, let's request mapping or request map. Anyway, we'll say employees list. And we will do models put. Why it always autocomplete into compute? Employees, and we'll do employee DAO get employees, something like this. And then we'll say return employees list. So notice that I'm going to return a view name called employees/list, and that's because I want to create a subfolder here for my employees views. So let's do that, and let's say employees list. The folder is going to be called employees, and the JSP will be called list. And it will be say employees, and then I need to use JSTL to iterate through the list. That is something I cannot remember. I'll have to copy it from here. Okay, so we'll need that tag library. And then we should have our employees here. Let's create a table with a border. And we'll say, what do we say? let's not even use a table, since there's really nothing too much in the. Where is my since there's really not much in there, we'll just show employee name in a list. So we'll say C for each items is employees, and the var is employee, and for each one we'll give it a list item which give us employee and give us employee name. It is name, right? It is name. Okay. All right, so this will be our controller. This will be our view. Let's see if it works. What's the URL mapping? Slash employees slash list .html. Let's try it. So we go to employees, we go to list.html, we get an error that says unable to acquire JDBC connection, and why it cannot acquire the connection. No suitable driver found for this. Maybe we do need to specify the driver name. Maybe we do need to specify the driver name. So let's add that thing back. I think the new driver is called CJ driver or something. Let me quickly search MySQL CJ driver. It's called MySQL CJ visitor. Okay, so that's the new driver name. And let's try this again. Okay, so we see the application running, and let's go to employees list.html. It gave us Sue, Joe, and Tom, so great. Now it works, and from this example, we see some controller basics that we already saw. We have a controller annotation to create a controller. Where is it? Yeah, and we have request mapping, we have model map, and the new thing here is the DAO. So we are auto-wiring the DAO implementation in here, so nice and simple database access code. And then let's do display an employee. So display an employee, we can of course do something like this. We can say, instead of list, we'll say view.html question mark ID is 1, for example. So let's do that. And we'll do a request parameter. Where is the controller? Okay, here. So let's say we are going to have request mapping employees view, and this one will say view model map, and but in addition to that, we also need the ID say request param. Is it request param? Yes, request param. Request param integer ID, and then we'll do models put y employee, and then employee now get employee, and then we'll return employees view. So as you can probably guess, this one tells Spring that integer ID is a request parameter. So when a request comes in, it will try to convert the request parameter into an integer and pass it to the controller message. And let's go here and create a few links. We'll say this one, we are going to do a view.html ID is employee.id, and okay, so if we go back here and refresh, and if we click on it, it gives a for that says view.jsp is not found. That's correct. That's because I haven't created yet. So this one we'll call it view.jsp. And here we just display the employee is employee.name. And let's refresh. So it says Sue, and if we click Joe, it will say Joe. So this is how we can use request parameters. You just use an annotation to tell Spring there's a request parameter. Please convert it into a method argument. Now, there are another way to do requests. There's another way to get user input. Instead of using a request parameter, we can use something called pass variable. So a pass variable is something that's part of the URL. So instead of saying view and then question mark and something, we can just put the value directly in the URL. And of course, then it's no longer a request parameter. In Spring, it's called a pass variable, and we'll call this view2. And we can actually still use the same view. So we'll call this view2 and still use the same view. And also, we are going to change this one so that it has two links. The first one is employee name, and then the second one is using pass variable, and this time instead of view.html, we put the ID directly in the URL. So yeah, something like that. And let's get back and then refresh. Okay, so it says use pass variable. If we click on that, it still works. I'm not sure if you can see this, but notice that now ID is part of the URL. See here. So in this example, we showed two things: how to use request parameter, how to use pass variable. And in fact, you can specify a lot more when you create a controller method. And after seeing these examples, you can kind of tell how where things are going. If basically in Spring, if your controller method needs something, you can create a method parameter for it. If it doesn't need anything, like in the index controller example, then it doesn't really doesn't have to have anything. But if you need anything, whether it's a request parameter, whether it's a pass variable, whether it's a whole bunch of some other things, you can just create a method parameters for it. And this is a list of all the different things you can pass to a controller method. If you want to access, for example, servlet request response directly, you can do that. If you want, you can also access a request as a web request, which is a Spring API request. You can access session. You can access the current logged in user called principal. You can access all kinds of other things. So I want to mention, yeah. So sometimes if you omit an annotation on a parameter, it will fall under the any other argument category. If you read this documentation, you'll see that based on the type of the parameter, Spring will either try to treat it as a request parameter or a model attribute. So in other words, I think we can omit this one and it will still work, because if we omit request parameter, it will fall under the any other argument category, and because integer is a simple type, it will be treated as a request parameter. Okay, so let's do one more, and this one will add an employee, and this is a good one because we are going to use request method and a new view redirect. So how do we add an employee? Well, we need a form first. We can create a separate page. Actually, let's just create a separate page. Why not? It's not that difficult. We'll say add, and here we'll have a form. The method is going to be post, and we'll say new employee name, and we'll have a type text, and what else? We'll have a name, and then let's put a button here that says add, something like that. And then in our controller, we'll do something like this. We'll say request mapping employees add, and the method is going to be case request method get, something like that. Okay, I think this one is correct. And now, because we have a second attribute for the annotation, we have to specify the name of the first one, and the name of the first attribute is value. And if you only have the value attribute, then you can omit value. But now we have two, so we need it. And this one will say add, and this one will simply return the add JSP. And then we're going to have a post. Let me just copy this thing. So this one will be post, and this one will have actually I'm going to try without specifying request parameter. I think it should work. So this one is string, and then we are going to do an employee down, save employee. We are going to create a new employee. Okay, I think this is not C#, cannot do it one shot. So let's create an employee E is new employee, and then e.set name is name, and then let's save it. So after saving it, we want to do a redirect. So we'll say redirect to index, not index, redirect to list.html. So this is a special view. If you want a redirect, you say redirect column and then the URL where you want to redirect. And now let's add a link here. So we'll say add.html, add employee. Okay, so let's see how it goes. We refresh, we click add employee, cannot find add.html. Oh, it cannot find add.jsp. I do have add. Oh, okay. Run name. So this one is not just add, it has to say employees add. Okay. Okay, so let me just restart it myself. Okay, so let's go to employees list HTML. Let's go add. Let's say we add a Jack. So Jack is here, and we can verify that Jack is here. Okay, so this is how we can add something, and this example shows the usage of method in request mapping, and as we mentioned, you can use one of the shortcuts that combine the URL pattern and the method. For example, you can use a post mapping instead of request mapping plus method. And we also saw the redirect view, and to add a new employee, we could do what we did here, which is to get the individual fields and then combine them into an object. Simpler way is to just bind the data into an object directly. So we could do something this instead. We can say, let's get an employee object, and this employee object is going to be a so-called model attribute. And then we just save that. So in this case, this object is known as a binding object or a binding model. So the Spring will take the fields in the form and try to set those fields into the properties of this object. So we should get the name property for this object, and then we can just save the object directly, much quicker that way. So we can try this again, and this time we'll have Jake. Let's say we'll have Kate, and so it works, and it works here. So notice that this time we are using the model attribute annotation, which makes this a binding model or binding object. Okay, so this is the end of this video. For additional readings, please check out chapter 1 of the Spring Web Servlet documentation. See you in the next one.